recording is done. All right, good morning everyone again. So today we're gonna do paper 5 correction first because next Tuesday we're gonna have our paper 5 SAG. Now let's do question 1 first. Let me just make a few comment on this question 1. Some of you did very well in your paper 1 here. Yeah. Some of you miss a lot of step. Yeah. For 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 example, like this one, you want to find out the deflection of the uh, stripe or strip. Yeah, you want to find the deflection of the strip. Yeah. So some of you mistaken that you want to find this one. Yeah. Let me. Yeah. Some of you mistaken that you want to find this one. So instead of your drawing, you put a ruler here. You put a ruler here, and then you said you want to find the deflection. Find the deflection. So I was very kind of like very worried. Why you choose? Why you put the ruler horizontally? Because if you want to find out the deflection, it has to be this one. Yeah, it has to be this the vertical ruler. Yeah, not the horizontal ruler. So the ruler should be placed like this. Ruler. Yeah. So the ruler should be like this, so that you can get the first reading. You can get the first reading, and then the initial reading and the final reading to get your S. So this is something I find it very weird lah. So for you to recap back lah, and then for oops, and then for this one, the next thing I want to comment is because it has a level point P here. See, there's a level point P here. So when I check your drawing, most of you did not label the point P here, and then the mask should be at the somewhere near the point P. So if you can maybe just like this, yeah, at the center of the mask will be at the center of a point P. So you can say this is the lot, yeah, or you can say this is the mask. Okay, it's up to you to call them lah. Yeah, you want to call it lot also can, and call it mask also can. So some of you miss this picture here, and then of course you need to have some sort of a clamp. You need to have some sort of a clamp to help you to make the ruler uh, vertical. So you can use a some sort of a retort stand. So can put like this. Some sort of retort stand, put like that. Yeah. And then you can also draw the leg of the retort stand. So this is the, oh sorry, maybe the leg is here at the top there. Yeah, something like that. Yeah. So this is the retort stand, and then this is your clamp lah. Yeah, this is your clamp, because you need it to be vertical, right? So another thing you can do is you can add the set square here to make sure that the ruler is vertical. Set square. Yeah. So this is one of the things that you must put in your diagram to get the mark lah. Something like additional information. And then the next thing is over here. Yeah. The next thing is over here. You need some sort of a support to make sure that the stripe did not fall down from the bench. So there are many things you can do. You can actually put a heavy mask, a very heavy mask on top of the stripe. You can use a heavy mask, or you can use some sort of a clamp. Yeah, you can put some some sort of a clamp over here, yeah, and then G G clamp lah, yeah, a G clamp over this stripe here, so you will not be able to fall down. So this is something that they want to see lah. This is something that they want to see from your question number 1. So the next thing I want to talk to you is this one. I'm very surprised that some of you are unable to determine this one. Determine the independent variable and the dependent variable. So independent variable is something that you, independent vary. Something that you vary, and the dependent is something that you measure. Okay, so there are a few of you unable to solve this one, and then one of you or maybe two of you write the other way around. Yeah, so how do I know whether this is the dependent variable or the independent variable? Here is this statement here. Okay, so you need to read this statement carefully. Yeah, so there are S and L in this statement here. So that means this one must be the independent variable and the dependent variable. So how do I know which one? You need to read the front page again. So this student want to investigate the bending of a loaded wooden strip. Show a rectangle. A lot is positioned. This causes another to bend. Okay, it didn't say much. So uh, you have to bear in mind that there are no multiple strip used. If you look at the question, you only have a. Yeah. Let me write. Let me show you. Yeah. So what you need to do is you have to vary the L actually. Yeah. Vary the L. Measure the S. So most of you are able to give me the correct answer, and then if you look at the formula here, then you will know that the constant will be a lot there. Yeah, there will be a lot of constant. The constant will be the mass, the G, the E, and then the B, and then we also have the T. And bear in mind that since G is a constant, we don't need to explain. And because this is what we want to find out, yeah, this is what we want to find out to determine a value for the E. So this one also we no need to explain. Yeah, this one we no need to explain. But for the other one, sorry. But for the other one here, yes, we need to explain these two here. So when you mention M is a constant, you get a 1 mark already. When you mention B and T are constant, you get another 1 mark here. All right. So one thing I find that most of you make a wrong choice is B. Yeah. Okay. B. Let's look at B here. What is B? Okay. Let me write off this part here. This is your B. Eh? So just to show you that this is the B. Now, this B here, most of you write down using a ruler. Okay, using a ruler. To be fair lah, there is no mark given for the B actually. Yeah, there is no mark given for the B. There's only mark given for the T lah. So it's alright lah. I think I no need to talk about B lah. Just they use ruler, I think. Yeah. Let me double check again the scheme. Okay, past year paper. It's a November paper, November 1951. I think it's 51. Or maybe it's 52. Yeah. I think it's a 52. Salah. It's a June, I think. Sorry, I don't remember which year already. Yeah, it's a June, I think. June 52. Salah again. Never mind lah. Just carry on saja lah. Alright. So you try to explain all the thing lah. All this thing here, how you find out the M using the balance, T using a vernier caliper or micrometer, and then try to repeat the measurement. So please make sure that when you write down repeat, you must mention the full sentence. So let's say you repeat T or B, yeah, at different location, not just simply one location, or you can say position also can, yeah, and then and average them. Okay, so this is one of the mark that you must always write down. Don't write down those zero error thing. So zero error is no longer consider one of the additional mark lah. So just write down this is good enough. Repeat at T and B at different location and take the average. Now another thing I want to talk about is your analysis. Yeah, most of you did good or did well in your analysis. So I just want to emphasize again how you do the analysis. So analysis, you want to make it something like the subject here. So this is the S and L. So you either you make S the subject or L the subject. So it's up to you. Okay. You want to make S the subject or L the subject. For my view here, I think S will be the best one. So you can make S equal to what's the whole thing again? 4mgl cube. 4mgl cube divided by EBT cube. It's both cube, yeah. So this one will be your statement here. So it's y equal to mx, yeah, y equal to mx. So this one will be your gradient lah. So remember the first mark must have plot at S against L cube. This is one mark here, and then you make a statement there. The gradient is equal to 4mg EBT cube. Okay, so you want to make E the subject. Always make E the subject because that is what you want to determine in the first place. So it will be 4mg gradient times BT cube, right? It looks very easy, yeah, but somehow some of you cannot do this algebra here. Yeah, I mean all this algebra here, you mess up. And the last one is you must write down valid if it's a straight line through origin. Why through origin? Because you see here, there is no y-intercept. Yeah, no y-intercept. So if there's no y-intercept, that means it will cut through the origin. All right. So these are the thing you need to bear in mind. Don't miss this point. Yeah. This is this three point here is a bonus. Yeah. This 3 point here is a bonus. So don't lose this 3 point here. All right. We look at question number 2 here. Question number 2, I'm very surprised. Some of you actually make a mistake on this one. Okay, some of you, when you make the gradient, yeah, it will be xc equal to 1 over 2 pi c and then 1 over f bar. Yeah, you want to make this xc the subject. So your gradient is 2 pi c only. Yeah, and then somehow you miss out the c lah. Yeah, and then here most of you are able to give me the correct answer. You just do 1 over f. Yeah, you get the answer here. I think most of you got the correct answer here. And then here also most of you give me the correct answer. It's actually from a 455 until a 2.22. This one is a 333 until 161. Now, the funny thing is, when you were asked to show me the uncertainty of T in XC, I don't know what happened. Some of you show me the uncertainty for this one pulang. One of the uncertainty for this one. I don't know why you show me the uncertainty for 1 over F. Yeah, it won the uncertainty of XC. Yeah, it's a XC here, so it must be this one. So the uncertainty will be the XC here. This is the correct one. You don't find the uncertainty for the frequency. Because if you find the uncertainty for the frequency, you end up the error bar will be horizontal. This one, the error bar is vertical, yeah? So how to get the uncertainty? I did show you last time. I did give you some tips last time. So how to get the uncertainty? The uncertainty of C is actually come from the V naught. V naught. Let me look at the front page. V naught over I naught. Yeah. So it's a V naught over I naught. V naught over I naught. So delta XC over XC will be delta X naught over V naught over naught plus the delta I naught over I naught. So you go and find out the uncertainty XC. It will be from somewhere 20, yeah, if I'm not mistaken. 20 to 7, yeah. 7 or 8, yeah. All right. Now, another common mistake is after you find out the uncertainty, remember, you must find out two things. You must find out the gradient of the best fit line and also the gradient of the worst fit line. So these are the two things that you must find. Once you get the two gradient, the uncertainty will be modulus gradient of the best fit line minus gradient of the worst fit line. This this one will be the method lah. Yeah. Now, most of you, I think half of the class, you forgot to take note that the 1 over F is actually time 10 minus 3. Yeah. So when you get your point here, you always do the bottom one. You miss out the power of 10. So that's why you got a 0 mark here for the power of 10. So for your next coming exam, make sure that you check the power of 10, this one, for your axis. This one, most of you got it right, yeah. The best fit line, worst fit line, and also the point plotted. I think none of you got it wrong. Now, the next one here is the last one, the part D here. You mistaken this C here, yeah. So just to let you know, this is not a y-intercept, yeah. This is not a y-intercept. It is C, doesn't mean that it's a y-intercept. It's the value of C. So you need to use your first statement just now. The gradient is actually 1 over 2 pi C. So you make C the subject. C will be gradient times 2 pi. Yeah. And then you will ask to include the uncertainty of your value and the appropriate unit. Now, I seen that some of you still look at the gradient, the unit from the axis. Remember I told you last time, in order to know the unit, you look at the front page. C is capacitance, yeah. C is capacitance. It's already mentioned in the front page. So the unit must be farad, yeah. The unit must be farad. So you don't need to do so many work lah. You don't need to do so many work. You go and find out the second ohm minus 1 kah? Yeah, something like that. I don't remember the answer already. So you give me this unit here. Is acceptable, but we advise this one lah. Yeah, it's the farad. And then you will not be penalized here because you use the error carry forward from your gradient. So this one, the answer must be something time 10 or minus 6. That will be the correct answer because it's a farad. Yeah. Yeah. And then the uncertainty. How to get the uncertainty? There are two ways. Yeah. There are two ways to find the uncertainty. You use the C you use the C for the best fit line, and you use the C for the worst fit line, you minus, you will get the uncertainty for C. Or you can use the formula on the right hand side here. You can use this formula to get the, use this formula to get the C also. So the uncertainty for C will be delta C over C equal to delta gradient over gradient. So you can get the delta C from here also. So both method will work. Yeah, you can use this or you can use this also, no problem. And then the part E, part 1 is the free mark also. You are given already the R, so you want to find out the time, right? So time is your value from C times the R. So your C value you substitute here, you should get the answer correct. Yeah, not a big problem. Now the last one here, some of you are unable to answer. So let us see why this one is hard. Huh? Now, isn't that your formula for the time is C times R? So you want to get the percentage uncertainty for your time. You want to get the percentage uncertainty for your time. Like this. It will be the percentage uncertainty for C plus the percentage uncertainty for R. So this one is already given. This is a 10%. Yeah, it's already given here, 10%. So what I need to do is you look at your C. Yeah, you look at your C. So this one is your value of C here. So you just substitute the value of C, the uncertainty, and then you time 100. Then you plus this all, you should get the answer already. Yeah. So that's how you do the question number 2 lah. Yeah. Alright. So let's have a look again. Is everybody here? Oh, yeah, everyone is here. Alright. So please for this coming SAG paper 4, make sure you don't lose mark in all this. Alright. Make sure you don't lose mark in all this. I seen that some of you lost mark in the graph. Why? Because the error bar you draw terbalik. Yeah. Instead of the error bar look like this, your error bar look like this. Why? Because you use the delta 1 over f, which is the wrong one. You have to use the delta xc here. Yeah. In order to get the correct uncertainty. Okay, any question about your correction? Anything you want to ask me? Ada yang kan tanya? Anybody want to ask something about your paper 5?
Sir,
Yes.
about the marks for yung question 1, like
Okay.
berapa untuk each part?
15. I mean,
For like each part macam for the analysis and then for the extra information.
right. Let me just show you. I think I saved it somewhere. Question QA. This one I think. I think ada sini. Wait Alright. So for defining the problem so let me just show you here. Defining the problem. So this is one part. This is a 2 mark. Never mind. It's this one. 2 mark for the defining the problem, and then the method of that data collection will be this one, which is a 4 mark. Yeah, so I write down here dulu lah. This one is defining the problem is a 2 mark. Method will be 4 mark, and then analysis analysis is here. So this one will be 3 mark. Yeah, so this one will be 3 mark. And then because it's 4 plus 2 6 6 plus 3 is 9, so that means the additional information here is 6 mark here, 6 mark here for all this, any 6 lah. Yeah, any 6. Dia dah mentionnya maximum 6. Alright, so the other what do you call that? Point that you must taken. This one, I always tell you this one. Okay, repeat reading at different position. This one, different point along and then take average. This is the most common one. And then for point here, determine T, micrometer or caliper here. The mark scheme didn't mention B. How you measure B? Nada bah? I remember nada. Somehow B itu not very important in this paper here. So remember, it's a 6 mark for additional, 3 mark for analysis, 4 mark for data collection, and defining the problem will be 2 mark. Yeah. Any other question? Anything you want to ask me? So if there is nothing, yes.
Next paper 5 ni, how's the question?
Thank you for your question. So next paper 5 ni, it will be similar to, it's almost similar lah. Every year,
Okay,
you must,
noted.
Najwa payah lah. So I purposely choose the one yang doable one lah. Macam you can imagine one lah. I try to avoid those yang you need to. You remember the one that I asked you to do during the revision? You need to have a time lock to take the reading for very short interval of time. Kalau soalan macam itu adalah, ya. Soalan macam mana adalah. Mostly I will take those yang you are able to imagine how you carry out the experiment. Yeah. So we revise a bit more lah, just to anulah. Macam mana saja. Let's do one paper lah. Let's do one paper since we have time here. Let's do one of the paper and see how this thing goes lah. Past year paper. Alright, maybe choose 2001 tu lah. Yeah. November question number. November is 5-3, so it's 5-3. Alright, so let's try this one, 2001-3. Now, the first thing you do in your question 1 is, what do you need to look for is the statement. You have to look for this statement. Always look for this statement. Every time in your paper 5, there's always this statement here. So what does this statement do is that there are 2 variables, yeah, Q1 and pi. So that means your independent variable and the dependent variable must be one of them. Yeah, it has to be one of them. There are no other choice already, because this is what you want to do. You are suggested that theta 1 is directly proportional to the wavelength of the light source. So this is the theta 1. Where is theta 1? At a particular theta, at a particular angle, 2 sources appear as a single source. Okay, 2 sphere. Okay, so theta 1. So in this case here, you have to design a laboratory using 2 light sources to test the relationship between theta 1 and lambda. So for this case, you need to think of what you should vary. Should you vary the should you vary the theta 1 and measure the lambda, or should you vary the lambda and measure the theta 1? So for me, this one is more doable, yeah, rather than this one, because wavelength mean web length mean color, yeah, color. So if you have the, if you vary the angle, but you measure the color, it looks weird. So we can use different color. We have a different light source, and we measure the angle. Theta one will be make more make more sense lah. Yeah, make more sense. All right. Now we don't have a this question a bit weird. We don't have any analysis statement here. Analysis. By the way, anything below 2015, this is a 2000, this is a 2012. You can see that the question is a bit harder. Why? Because there is no formula for you to analyze. Yeah, there's no formula for you to analyze. The constant and so on is also don't have here. So the source are moved closer together at a particular angle. The two sources appear to be one. The two source angle between is large. View from distance. So what should you keep constant? What should you keep constant is probably, yeah, probably the intensity of your light. Yeah, probably is the intensity of the light source, or simply the brightness lah. Okay, so this one has to be the same brightness. We cannot make the distance constant because we are moving. Yeah, this one is moving left and right. Yeah, it's moving left and right. Moving. Oh, sorry, it's not moving left and right. Sorry, it's moving up and down. Yeah, it's moving up and down. The source are moved closer together, so that means it is moving up and down here, closer together. So you can say the distance here, you make it the make it the same lah. Okay, so another one will be the distance to light source and the observer. Yeah, so this one you can make it constant. Okay, so these are the things that you can make it constant. Now is the analysis. What should I do with the analysis? If there is no formula involved here, okay, and then pay attention, arrangement. You should pay attention to analysis of the data. Analysis. This is not about young slit or double slit. Very interesting. Let's have a look at the mark scheme here. This is a 5. This is what? 5-3. Yeah. Okay. Let's have a look at the 5-3. How did they do the analysis here? So this is a 5-3. So you vary the lambda. You measure the angle. Yes. Light source similar intensity. Done. So determine the analysis. Wait, oh, so it's just direct. It's just a direct one only. Plot theta against lambda. Yeah, plot the angle against the lambda, and then relationship valid. So that mean for this one, we only know that theta 1 is proportional. So theta 1 is proportional to lambda. So you can make a formula from it. So y equal to yq. Theta 1 is equal to k lambda. So you plot lah. You plot theta 1 against lambda. If it's a straight line, yeah. If it's a straight line through origin, then it will be correct lah. Yeah, valid. Okay. Let me check again. Normally the analysis is 3 mark. Yeah, but for the old one, the analysis is only 2 mark here. Yeah, this is only 2 mark here. So there is a slightly different mark allocation for paper after 1.5 and before 1.5. So after 1.5, the syllabus change. So the paper 5 somehow the mark allocation will be slightly different. Yeah. So for this case, it will not be applied, but somehow we need to make sure that we know how to do this. Yeah, this is more important. Yeah. What to be keep constant and what to be the variable and the independent variable and the dependent variable. Right. So safety precaution, we have a lot here lah. The lamp is hot, so therefore do not touch lah. Do not touch or switch off when you're not in use, and use glove when you're moving the hot lamp. Yeah. Because it's very bright also. Wear dark glasses. Do not look at the unprotected lamp. And then also you can use vertical filament lamp. This one, okay. You can find out the wavelength using the Young slit or diffraction. Yeah, just mention. Yeah, in all of this lah. So basically, that is how you do question 1 lah. I think we better don't try this one because it's not the same as the current one. But let's try question number 2. Last one for today. So question number 2, normally there is a formula they will give you. So this is the formula normally they will give you. So what you need to do first is you need to make v square the subject. So you slowly move it first. So v over a equal to square root of k over n. And then it will become v square over a square equal to k over n. And finally, the v square is equal to, you want to make 1 over m the subject. So it will be ka square. Yeah, so the gradient will be a square times k. Yeah, correct ba? My math should be okay lah. Yeah. And then for this one, be careful lah. You look at the power of 10 first. Always check the power of 10. This one don't have any power of 10. This one don't have any power of 10. So it's just direct. Yeah. So 1 over m easy. Just divided by the mass here. And the v square, how you get the v square? You have to use this from the top here. Yeah. Here. Sorry. V square. We'll get the v square. Any formula about the v square? Distance. You have the L. You have the length here. Distance over time. Yeah, well, how to get the v square? Let me see here. V square equal to a square k1 over L. A student study how the maximum speed vary with the total mass. The maximum speed is determined using the time taken. The maximum speed is determined using the time taken for the cut to pass through a light gate connected to a timer. The length of the cut is 5.0. Oh, okay. So this is the distance. The distance. And the time taken to pass through the light gate is using for the cut to pass through a light gate. The length of the light gate is this one. So that means you use speed equal to distance over time. So the L over the T. So the L over the T, L is given, your T is given here. Then after that, you have to square. You have to square the answer here. Then you should be able to get the answer here. Okay. So this one done. This one done. And then finally, how you get the V square? So remember, the V square is coming from L square over T square. So your L square at the beginning, you have this one already, you see? This is your L square. Okay, this is your L, sorry, this one is your L. So you have to do the standard one. It's a square. It's a square. So delta V square over V square is equal to 2 delta L over L plus 2 delta T over T. Yeah. So it's quite quite long here. Yeah. In order to get the uncertainty here, you need to use this formula. Yeah. And finally, you plot. You go and plot the error bar, and then you draw the best fit line and so on. And then the gradient, the same step lah, yeah. The worst fit line minus the best fit line and so on. All right, and then we have this one. So this one again, it does not ask you to find the y-intercept. So you need to use the gradient that you found earlier. So it's a square k. So you find the a. This is you find the k. This is given. So you can find the k. Uncertainty, no need. Yeah. Here you need to find the uncertainty percentage. So it's the same one. So k is equal to gradient over a square. So the percentage uncertainty of k will be percentage uncertainty for the gradient plus percentage uncertainty for your a time 2, yeah, because it's a square. Then done. All right, so this one you use the original formula from the beginning, yeah. The last one you use the original formula from the beginning, which is this one. Maybe just take it down here, copy it down. So the last one, you just simply put it there. Yeah. So just simply use this one lah. Yeah. So you have your mass. This one is given. This one will be your mass. K already you found out. Yeah. And then A displacement. The initial displacement determine the maximum speed of the. Can you find the maximum speed? A. Okay. Initial displacement. Do I need to include the displacement? Yeah. No need, correct? Yeah. Initial displacement. So I think you just use the ano lah. You can try lah this one. So maybe now after this, yeah, I like everybody to look at you try do question 2 and see whether you get the answer or not. See you can get the answer or not. Okay, I think that's it for today lah. So what I want you to do now is you do this past year. You look at your past year book, yeah, your past year book, the purple color one. You do this one, you do question 2 or maybe question 1 lah, and you try to practice how you calculate all this. Any problem you let me know lah. Yeah. So remember, it's Tuesday Tuesday afternoon your SAG paper 5 and then the following week will be paper 4. So paper 4 I give you the pointer already. So those are the topic that will be tested lah. So try your best to practice the topic that I share with you, and good luck lah. All right. So if you have no question, you can go now, yeah, and do the thing.